And just checking everything. Okay, so in this lesson, we're going to do more equation solving, ladies and gentlemen, but we're going to have a look at some special properties of sine and cosine and tan in order to make this happen. So I'm going to start with, let's start with a right angle triangle. No, I won't. The hint to this is that think about right angle triangles. So I'm going to give you a problem. And the problem is sine of theta is equal to 0.6. Okay, whatever. That's not the problem, that's just your information. Question 1 is what's the cosine of pi on 2 minus theta? 90 degrees minus theta. Going to give you a moment to work that out. Talk to the people next to you, or if you're watching this video back, just pause. Okay, hint number 1. Sometimes when you've got a problem, drawing a diagram helps. Now, I know that theta could be any possible angle, but the behaviour of theta is the same regardless of whether theta is obtuse or reflex or whatever else. So let's focus on an acute theta, and let's draw a triangle. And I'm not going to fill in all the information. I'm going to give you a right angle triangle there. Let's put theta down here, and let's make the hypotenuse of length 1 arbitrarily. Use that and see whether you can answer the question now. Here's hint number 2, and if you're watching this video back, I hope you're pausing after each one. Here's hint number 2. 0.6 equals 0.6. I know you don't normally write fractions like this, but it's equal to 0.6 over 1. You could write it like that, because anything divided by 1 is just itself. So 0.6 can be written as 0.6 over 1. How does that help you fill in information on this diagram? So here's the third hint. That is a right angle. Please remember that in radians, a right angle would be described as pi on 2 radians. If that's pi on 2 and that's theta, is there a missing angle here you can now fill in with respect to theta? So for example, if this was 30, what would that be? If this was 10, what would that be? If this was 65, what would that be? Does that help you? Okay, so let's bring it all together. Whatever angle this is, this one plus this one must add up to 90 degrees. I really like what Anna did. She labelled it alpha up the top there and then tried to figure out what alpha would be. I quite like that. So if I do that down here, I would have theta plus alpha equals what? 90 degrees, or pi on 2. Good. Okay, those two must add up to 90 degrees or pi on 2. Therefore, alpha must be pi on 2 minus theta. Okay, so can you remember what we call the two angles that add up to 90 degrees? Starts with C. Don't swear. Complementary angles. Okay, they're complementary angles. So we have this special relationship where these two angles are complementary, and that does something to our sine and cosine. So we've got sine equals opposite over hypotenuse, which is equal to 1 for our hypotenuse, which means our opposite must be 0.6. Okay, so I can label my side here as 0.6. It's got to be. Yeah? And remember, the triangle is big or it's small, but the ratio remains the same. So the fact that I've arbitrarily given it a hypotenuse of 1 doesn't matter. If I had a hypotenuse of 2, then the side value there would be 1.2, double it. So if I double each side, the angle remains the same. Okay, so we've now got 0.6. Now this is the trick. If this is opposite theta, then it's adjacent to alpha. Yeah? So because sine deals with opposite and cosine deals with adjacent, then sine's opposite is cosine's adjacent. Sine's opposite is cosine's adjacent. Okay? It's going to give me the same value. So we will have the cosine of alpha being adjacent over hypotenuse, which also equals 0.6 over 1. Okay, so in other words, it evaluates to the same number. And cosine of alpha is just cos of 90 degrees pi on 2 minus theta. Okay, so cosine alpha equals sine theta. Let's put that down as a general statement. So in general, the sine of theta is equal to the cosine of pi on 2 minus theta. This is called a complementary angle relationship. Okay? Complementary because theta and pi on 2 minus theta are complementary to each other. Can you see how that's a vice versa relationship as well? I hope this follows. Cosine of theta would be equal to sine of pi on 2 minus theta. Because cosine's adjacent is sine's opposite. So it works both ways. So if I asked you, if I said cos of theta is 0.6, then 0.6 would be down here, which would be opposite this angle here. So the cos of theta would be sine of pi on 2 minus theta. Okay, get those two. I'm going to move over onto the next page, so write those two statements down, because on the next page I'm going to give you a question to answer. It's not one that I've shown you. Anyone need more time?
Yeah.
Yep. Okay. See if you can answer this. Cos of theta equals sine of pi on 12. So what's that? Half of pi on 6, so it's 15 degrees. Okay, so that's 15 degrees. So cos of theta equals the sine of pi on 12. Without your calculator, what's the value of theta? You have enough information to solve that, believe it or not. I'll pause the video, but I'll give you a couple of minutes to have a crack at that one. That will help. So there's a couple of ways you can think of it. One's more intuitive than the other. What I showed on the board a moment ago would work like this. You could say that cos theta is the same as sine of pi on 2 minus theta, because we just did that. And that equals the sine of pi on 12. Therefore, pi on 2 minus theta equals pi on 12 by equating arguments. Which means if I add theta to both sides and subtract pi on 12 from both sides, I get theta equals pi on 2 minus pi on 12. And I would normally do this bit in my head, and you can too. Pi on 2 is 6 pi on 12 minus pi on 12, and that's 5 pi on 12. So that's the equating arguments. Honestly, I could have skipped a whole bunch of this. If you remember that we said that cosine and sine are equal with their complementary angles, I could have simply said, if this was sine, if this angle is sine, then this angle must be 90 degrees or pi on 2 minus, because that's how we get the complementary. So I could have really just gone straight to here. I could have just said, let me work in degrees to make it easier for the understanding part. If this is the sine of 15 degrees, then theta must be 90 minus 15 because they're complementary. Yeah? Okay, cool. Now, there's one thing missing from this, and that is we're assuming that theta is complementary. Sorry, say that again. We're assuming that theta is acute. So I'm only looking for an acute angle here. But what happens if it's not acute? What happens if I just say theta is between 0 and 2 pi? Then we're going to have more solutions like we were doing yesterday. Okay. Get that out of the way. Try this one. This is going back a step, so you might find it easier. So let's say cos of theta is equal to 0.8. What's the sine of pi on 2 minus theta equal to? 30 seconds to do that. I'm not even going to pause the video. Okay, 0.8, right? It's the same relationship, that the cosine of theta must be the same as the sine of 90 degrees minus theta. Okay, so the solution looks like this. I mean, you just do it, I think, but I'll be a little bit more comprehensive for the notes. That's equal to cos of theta, which equals 0.8. But again, that's assuming that theta is an acute angle. It's a bit different. There might be more solutions if we take theta long for a long. No, actually, for this one here, it doesn't matter. It would just be 0.8. Okay, here's one more to try. Then I'll do that on slide 7, similar to the one we just did a second ago. So sine of theta equals cos of pi on 5. What's theta? I'll pause the video, give you a minute to do it. Okay, so solving this, again, it's okay if you didn't quite get there. Theta equals 90 degrees minus whatever pi on 5 is. So pi on 2 minus pi on 5. The reason why is because they're complementary. Oh, if I could spell. Because they're complementary. Now, we've got to find a common denominator. So the common denominator of 2 and 5 is 10. So that will be 5 pi on 10 minus 2 pi on 10. And that equals 3 pi on 10. Again, assuming that theta is only in the first quadrant. Okay, assuming that. Next one. I'm going to add one slight change and it will make a big difference. So I might even go to 2 minutes for you to solve this one. Sine theta equals cos pi on 5. Ready for the change? Got to watch carefully, otherwise you'll miss it. Sine theta equals negative cos pi on 5. What is theta? Okay, let's sort this one out. First things first, I think most people, I only say that because I didn't go around every single person, could see that if this is sine is negative, then the angle must either be here or the angle must be somewhere in here. But either position here would be a solution. Now, we know that sine of theta is equal to negative sine theta hat, where theta hat is the acute angle between those two places. Okay? So that must be theta hat there, and that must be theta hat there. So sine of theta hat will be the acute angle. Sorry, theta hat will be the acute angle, and so sine of theta hat made negative will be equal to sine of theta. Will?
Oh, no. It's fine.
You sure? Okay. Are we okay so far? No? Where have I lost you? So let me go back a step then, because this is what we were doing last week. I'm going to flick over to another page, but I'll be back. So going back to standard, you know how like the sine of 60 degrees, what's that equal to? A half, isn't it? No, it's root 3 on 2. 60. Yeah, it's root 3 on 2. Remember from your table, sine of 60 is 100 and is root 3. Ah, damn it. The sine of 60 degrees is root 3 on 2 from our table. Yeah? So that means the sine of 100 and 240 the sine of 240 degrees is equal to the sine of this internal angle here, which is 60 degrees. But because it's in the third quadrant, it's negative. Yeah? So this is basic, this is fundamental cast diagram stuff, where the sine of the angle, the big angle, is given by the sine of the acute angle, the angle between the x-axis and the line, but then you just have to put a positive or negative in front of it, depending on what quadrant it falls in. So the sine of 240 degrees is equal to the sine of 60 degrees, but negative because it's in this third quadrant here, because only tan is positive. Okay, so from our cast diagram, cosine is positive, all is positive, sine is positive, and tan is positive in the third quadrant. So sine is negative in this quadrant, so the sine of 240 is negative sine of 60. Is that okay? Okay, in other words, it's the same coordinate as the sine of 60, but because it's down here, the y value is negative. So it's negative sine 60. Same value, but it's negative. Okay? So what I'm saying here, now this is dealing with 60 degrees and a value we already know. So this would be the sine of 240 degrees is equal to negative root 3 on 2. What I'm saying here is that cos of pi on 5 is a value, doesn't matter what it is yet. Well, it doesn't matter what it is actually, but negative cos of pi on 5 means the angle must be either here, all the way around here, or all the way around here. Now, if we can work out what theta hat is, then we are good to go. Yeah.
Can it go around more than once?
Yeah, good, really good question. I'm assuming it's between 0 and 2 pi here to make it simple. Really good question. Always good to question the domain. So we're making the domain between 0 and 2 pi. Okay, so what do we know about cos of pi on 5? We know that cos of pi on 5, this is the acute angle, cos of pi on 5, is equal to the sine of 90 degrees minus pi on 5. Okay? Which is equal to what we got before, which was, what was that? 3 pi on 10, just from the last question. Okay? So that means that must be the acute angle, theta hat. Okay? So because of this relationship that they're complementary angles, if cos of pi on 5 is equal to, well, if we've got cos of pi on 5, then it means the complementary angle is 3 pi on 10. So that's 3 pi on 10 there, and that's 3 pi on 10 there. The acute angle. Now, frustrating, we have to go to the next page, which is going to make it a bit tricky. So let me just do the verbal, then I'll flick pages. This is the acute angle I've worked out, 3 pi on 10, which means that theta has to be pi, 180, plus this little angle here. Or it has to be 2 pi minus this acute angle. So I'm sorry I have to flick over, but there's not much I can do about it. So therefore, theta is either pi plus 3 pi on 10, which equals 13 pi on 10, or theta equals 2 pi minus 3 pi on 10, which is equal to 17 pi on 10. And there's our two answers. Okay, so quite tricky, that question. I'll flick back to that page in a second, but that's how you're doing. So how did I try and figure this out? I basically said that in order to solve this problem, I need to know what the value of sine theta hat is. Okay, the sine of theta hat. Sine of theta hat, I was able to work out by looking at cos of pi on 5 and then working out what the complementary angle would be, which is 3 pi on 10. Now that I've got 3 pi on 10 as theta hat, I can then work out what theta is by adding it to pi or subtracting it from 2 pi to get theta. That's about as tough as you can get. Okay, because we've got it on video and I've got a bit to get through, I'm going to keep on going. So apologies if you haven't quite got it, but go back onto the video and see how you go. Alrighty. What's the time? All right, with 10 minutes to go, I do have another pair of complementary angle results to show you, but considering that your brains are probably getting a bit too fried now, I think I'll leave it for Friday, knowing that I won't be here on Wednesday. So you're tackling exponential graphs tomorrow, but I'm going to have to carve out a bit on the Friday's lesson for this little bit of understanding, or maybe I'll put it into a video, I'm not sure. But I'm going to give you a much more straightforward couple of... No, a couple of, they're called identities. I'm trying to think of the right word for it. Special properties, let's call it that. A couple of really simple ones. So here's one result. Okay, special properties. I promise you this is a lot easier. So how did we define, in the cast diagram, how did we define tan? We define tan as the gradient of the line. Now, the line has a rise of y and a run of x. So tan theta is equal to rise over run. Is that okay? Rise over run. But the rise is just sine theta, opposite over a hypotenuse. The run is just cosine theta. And so we have this special relationship, which is that tan equals sine on cos. Okay, nice, easy one. We won't go through a problem with this, but let me start a problem off and maybe you could finish it off. So it means that we can solve, believe it or not, we can solve problems like this. Bit similar to what we did before, but not quite. Solve sine theta equals cosine theta, right? Now I could do this graphically, but what I'm going to do is I'm going to divide everything through by cosine theta. Okay, so I'm going to divide the left-hand side by cosine theta, and I'm going to divide the right-hand side by cosine theta. Now, cos theta divided by cos theta, that's just a number divided by itself, right? So that's just 1. And sine theta over cos theta is tan theta. So that tricky equation ends up just being tan theta equal to 1. And if you have a look at your table of values, when is tan theta equal to 1? 45 degrees. So you can go tan theta hat equals 1, gives you theta hat equals 45 degrees, pi on 4. So if you're looking for theta between 0 and 2 pi, I'll do this really quickly without any assumption that you'll get it straight up. But looking at my cast diagram, that means theta must be here, or it must be here, because that's where tan is positive. Okay, so therefore, theta must be pi plus pi on 4, so that's 5 pi on 4, or it must be pi on 4. Done. Okay, so by using these, they're called identities. By using these identities, you're able to solve problems by simplifying an equation before doing it. Okay, that's the name of the game here, to simplify before we do it, but of course you need to know these properties. I think that particular identity is on your formula sheet, but if you don't know to look for it, then you won't know to use it. I need to move on to the next page. I've got 10 minutes. Oh yeah, this is a pretty good one too. Really nice and easy. That's what you said last time. Okay, here is a nice right angle triangle. Again, I'm using a right angle triangle because what I do works in all 4 quadrants, because it's just flipping the right angle triangle to the right spot. Okay, so if I have an angle theta here and I have 1 here, let's call this distance up here y, like we normally do, and this distance here x. Can you please come up with an equation using Pythagoras' theorem? I'll give you 30 seconds to do that. You can't solve it. You can't find a value for x and y. You just need to have an equation which has x and y in it, using Pythagoras' theorem. Okay, I hope this is a little bit more straightforward. Did you get x squared plus y squared equals 1 squared? I hope. 1 squared is 1, right? So it's just x squared plus y squared equals 1. But x is equal to cos theta, because it's opposite adjacent over hypotenuse. And y equals sine theta. So therefore, cos theta squared plus sine theta squared is equal to 1. Beautiful. So in other words, if you take, let's say 17 degrees, if you go cos 17 on your calculator and square the result, and then add sine 17 squared, you'll get 1. And it doesn't matter what number you put in, radians or degrees, that relationship holds true for any angle that you want to put in, as long as it's the same angle for cos and sine. It's pretty cool, isn't it? Now, language warning. The problem with this, which I can exaggerate by putting even extra brackets in, the problem with this is that cosine and sine in lots of branches of mathematics is used a lot, and having these brackets flying about everywhere when you're squaring them does make for a very messy looking problem. And this is not about being a neat freak, but when something is really messy and you've got heaps of lines of writing, then you can make mistakes. And so there's a simpler way of writing squares or cubes or whatever of trig functions. And it looks like this. So instead of writing that, we put the square after the function name. So the way we would write this is cos squared theta, with or without brackets. I think on your information sheet it probably doesn't have brackets. Sine squared theta equals 1. And that's how you would say it, by the way. Cos squared theta plus sine squared theta. Now, let's see if you can be the first class in history that doesn't think that means cos times cos and then multiply it by theta. It doesn't mean that. It's a way of writing it. It's a standard way of writing it. So you just need to learn it, just like you need to learn vocab in the language. Cos squared theta means take the value of cos theta and square it. Take the value of sine theta and square it. That is what it means. Okay, don't square the angle. Nuh-uh. You take the value, take the output from cos theta and square it. Take the output from sine theta and square it. If you add those two together, it'll add to exactly 1. So, very briefly, to finish off the lesson. Yeah, I've got time, easy. Let's have a look at solving this problem here. Let's say you're given cos of x is equal to 0.6, and you're asked to find the value of tan of x. Don't know what sine of x is? You need to work out what tan of x is. So here we go. Standard way of solving this. Let's do the chain, I suppose. I can work out tan of x if I know what sine of x is and cos of x, because tan equals sine over cos. Yeah? Well, I know what cos is, but I don't know what sine is, so I'm stuffed. But I'm not, because I just worked out that top right-hand corner there, that if I know what cos is, I can work out what sine is. So I'm just following it back. So the first thing I'm going to do is work out what sine is, and once I've worked out what sine is, I can work out what tan is. So it goes a little bit like this. Sine squared, I'll do it around the right way. Cos squared x plus sine squared x is equal to 1. So 0.6 squared plus sine squared x is equal to 1. Now 0.6 is something that I hope you can do without reaching for your calculator. 6 squared is 36, right? So this is 0.36. Plus, you wouldn't have to do it in quite this detail. Again, I'm doing it for the notes. So 0.36 plus sine squared x equals 1. And so sine squared x is equal to 0.64. I just took 0.36 away from both sides. Okay? So therefore, sine of x is equal to 0.8 because the square root of 64 is 8. So it's got to be 0.8. Okay? So I'm just going to continue this over here. Therefore, tan of x is equal to sine of x, 0.8, over cos of x, 0.6, and that's equal to 4/3. For those of you who can't see that, multiply top and bottom by 10, and you'll get 8/6. And then cancel down to get 4/3. So the tan of x is 4/3. All of that was done without your calculator, but by following a breadcrumb trail. And I just want to finish by summarising that last bit there. What you're doing is you're going, what tools do I have to work out tan of x? Well, looking at your information sheet, the one relationship you've got there is tan equals sine over cos. Well, I've got cos, so I just need to work out sine. How can I work out sine? Look at your information sheet. Oh, sine squared plus cos squared equals 1. It's called the Pythagorean identity, if you want to give it. It's like the Born identity, but not quite as good. Okay, so you've got cos squared plus sine squared equals 1, and you know what cos squared is. That leaves you with an unknown that you can figure out. Note that throughout that whole process, I never worked out what x was. I was never asked to. I was only asked to work out what tan x was. Okay, I'll leave it at that. I'll stop the video.